Imagine finding out that your crippling morning coffee addiction, or the exact reason you'd have perfectly straight hair, was actually written into your biological code by some Bronze Age nomad living like 5,000 years ago.
Right, which sounds like science fiction, but it's really not.
No, it's totally real. And I mean, you've likely taken one of those standard commercial DNA tests, right? You
Yeah.
spit in a tube, mail it off, and a few weeks later you get this brightly colored pie chart back.
Yeah, the classic pie chart.
Exactly. It tells you that you're like 40% this, 60% that, and it's fun. I mean, it makes for a great conversation starter at family dinners, but then, you usually just close the browser and completely forget about it.
Which is such a shame, really, because that pie chart is just the superficial cover of a massive, incredibly dense book.
Yeah.
When you take those tests, the company usually lets you download your raw data.
Right.
And it's this static, incredibly boring-looking text document filled with thousands of lines of code.
Oh, yeah. It looks like a spreadsheet from the 90s.
Totally. But that file is the entire library of your biological history, just sitting there on your hard drive, completely unread.
And unlocking that hidden library is exactly what our mission is for today's deep dive. We are looking at a platform called SpartaDNA.
Right?
It's this comprehensive web and mobile platform that essentially takes that raw genetic data you already downloaded from companies like, MyHeritage or Ancestry DNA, and it acts as this incredibly powerful interpreter.
It's like a massive magnifying glass.
Yes. For those of you listening who are insanely curious, who don't just want the top-level summary, this is the ultimate shortcut. We are bypassing the basic consumer results and diving straight into the deep end of personal genomics.
I love that, yeah, because it fundamentally changes how you interact with your own biology. I mean, the place most people naturally start when they upload that raw data is looking at their regional admixture.
Which is just like
Yeah.
where in the world your DNA comes from.
Yeah, exactly. But if you've used the commercial giants, they tend to give you results that are incredibly broad. You get labels like European or Asian.
Right.
And historically and practically speaking, scientifically, that is a massive, almost useless generalization.
Totally useless, right? Because saying someone is just European completely ignores the thousands of years of migrations, conquests, and blending that actually built that continent.
Exactly.
Okay, let's unpack this because I want to make sure we really grasp how SpartaDNA fixes this generalization. They use what are called specific admixture calculators.
Yes.
And you can think of these calculators like taking an X-ray of a famous ancient painting.
Oh, that's a good analogy.
Right, because if you use a standard scanner like the commercial DNA test, you just see the final modern landscape painted on the top layer.
It's just the surface.
Exactly.
Yeah.
But SpartaDNA lets you swap out the scanner settings. Suddenly you're looking beneath the paint, seeing the hidden sketches the artist made 10 years earlier, or even the original canvas underneath. Each calculator focuses on a highly specific historical era, or like a regional layer of your past.
What's fascinating here is why having multiple highly specific calculators actually matters.
Yeah, why does it?
Because it highlights the reality that human history isn't static. It is entirely about overlapping waves of ancient migrations. I mean, you aren't just one monolithic thing. You're a complex composite of thousands of years of human movement.
Right. And the tools they provide to look at these layers are incredibly specific. They don't just have one or two.
No, they have a lot.
Yeah. For example, there's a calculator called JTEST-14, which focuses specifically on European and Ashkenazi Jewish heritage.
Right.
But if you want to look at modern regional components across Europe and West Asia, you swap your X-ray scanner to the Eurogenes K13 calculator, which breaks those elements down across 13 distinct regional categories.
Exactly. And it extends far beyond Europe, too. I mean, they have Dodocad K12b, which tracks ancient migration routes in West Eurasia and the Mediterranean.
Oh, wow.
Yeah, and if you have heritage tied to South Asia or the Middle East or Mesopotamia, you would run your data through the Harappa World Calculator. It's specifically calibrated for those ancient regional genetic signatures.
That's so cool.
Or, if you want to measure the genetic legacy and the mixing ratios of Central Asian and Turkic peoples, there is a specialized calculator called Turkic K11.
But the one that really caught my eye in the research is called PuntDNAL.
Oh, yeah, that one is intense.
Right, because this isn't just looking at modern regions or recent history. This is deep, deep time travel.
Yeah.
We are talking about Neolithic and hunter-gatherer data.
Yes, deep history.
It's literally comparing your raw text file to ancient DNA extracted from people who lived thousands and thousands of years ago.
Exactly. The interface allows you to run your raw data through all of these different models. It's basically the difference between looking at a modern political map with neat, current borders.
Which don't really mean anything biologically.
Right, and looking at a historical topographical map showing the actual messy, complex movement of ancient tribes, farmers, and civilizations over millennia.
So if we are carrying the genetic echoes of, like, Neolithic farmers and Iron Age nomads, how do we actually track that?
What do you mean?
Well, because admixture is still talking about percentages and regions, right? Like 20% this, 10% that. How do we move from broad regional percentages to trapping an actual unbroken family line?
I see. You do that by looking at haplogroups.
Okay.
This is where we trace the direct, unbroken paths of your ancestors through deep time. SpartaDNA detects both your mtDNA, which is your maternal line, passed from mother to daughter,
Right.
and your Y-DNA, which is your paternal line, passed from father to son. And these lines accumulate tiny, harmless mutations over thousands of years, acting like a biological clock or a breadcrumb trail.
And what I love is they don't just give you a string of letters and numbers and leave you to figure it out.
No, they give you the context.
Exactly. They give you the narrative behind the code. I was looking at one of the factual examples from the platform, this prominent lineage called the EV13 haplogroup.
Oh, yeah, that's a very common one.
Right, so if your paternal line comes back as EV13, the platform tells you that this specific lineage arose about 5,000 years ago in southeastern Europe and the Mediterranean basin.
Originating right around the Iron Age, roughly 1550 BCE.
Right.
Yeah.
And it tells you that today it is found at its highest frequencies in the Balkans. It literally places your direct ancestor in a highly specific time and geographic place.
It's amazing.
And the way they visualize this is incredible, too. They use these interactive phylogenetic trees.
Oh, the trees are great.
Yeah, it's not just a list. It actually shows the ancestral projections branching out for both your parents, like a literal family tree going back millennia.
They also utilize PCA plots, principal component analysis.
Wait, pause right there.
Yeah.
Principal component analysis sounds like something from an advanced statistics textbook.
It is.
Well, how does that actually work for a normal user? Like, I'm not a statistician.
Right. It is advanced statistics, but the visualization makes it intuitive. Imagine a massive graph or a scatter plot.
Okay, scatter plot, I can picture that.
A PCA plot takes thousands of complex genetic variables and simplifies them down to coordinates on that graph. It visualizes the genetic distance between you and other populations.
Got it.
So you can see yourself as a dot on this graph, plotted right next to a cluster of dots representing an ancient Roman sample or, a Bronze Age steppe nomad.
Oh, that makes total sense. Oh, they also have these interactive pin maps, right?
The pin maps.
Where you can click around a globe and see the exact geographical locations of those ancient ancestors and even famous historical relatives who share your haplogroup.
Yeah, it really brings the data to life.
But I have to play devil's advocate here, because I know what you listening at home might be thinking. Does this system actually know who my ancient ancestors were? Or is this just highly sophisticated statistical guesswork, creating a really fun graphic for me to look at?
It is a completely valid question. I mean, when we are dealing with deep history and genetics, skepticism is healthy.
Absolutely.
But to answer your question directly, this relies on hard, extensive comparative science. It is not just an algorithm guessing in the dark to make you feel connected to a Roman gladiator.
Right, they have actual data.
Yes, SpartaDNA is backed by a massive, searchable encyclopedia and database.
Just how massive is this database? Because to make those kinds of specific claims, you need a ton of reference material.
Oh, it's huge. We are talking about 74,259 distinct, verified Y-DNA samples.
Wow.
41,729 mtDNA samples, and 36,711 ancient and modern G25 vectors.
It's insane.
To put that into perspective, that's like comparing your DNA to the entire population of a small city composed entirely of verified ancient historical figures and carefully cataloged modern samples.
Really?
When they plot you on that map, they are directly comparing your specific raw data against tens of thousands of academic samples.
That is staggering. So it's not just a generic average. It's a direct point-by-point comparison to a massive physical library of biological history.
Exactly.
But processing that much data, cross-referencing my one tiny text file with 70,000 ancient samples, I mean, that requires tools that usually never see the light of day outside of an Ivy League university.
Exactly. And this is where the platform really bridges the gap between a consumer hobby and professional population genetics. They utilize something called the G25 service to handle that heavy scientific lifting in the background.
I saw that in the sources. They calculate these G25 vectors. And they even have tools that allow users to simulate G25 coordinates from other older formats like GEDmatch K36 or calculate raw unscaled coordinates.
Yes, they do.
But what actually is a G25 vector?
Okay, think of a G25 vector as a highly precise GPS coordinate system, but for your genome instead of a map. It maps your unique genetic signature across 25 different dimensions, like longitude, latitude, and elevation, but expanded to capture the vast complexity of human DNA.
That is wild.
Yeah, it creates a mathematical coordinate that can be rigorously tested against other coordinates, and that leads to their integration of a tool called QPADM.
QPADM. I had literally never heard of this before looking into the research for this deep dive.
QPADM is a highly specific tool used almost exclusively by academic researchers in peer-reviewed scientific papers.
Really?
Oh, yeah. Anthropologists and geneticists use it to rigorously test models of population admixture. For instance, to prove exactly how much Neanderthal DNA is present in a specific modern population.
Oh, cool.
And the thing is, it is historically a command line tool.
Wait, command line, you mean like old school MS-DOS coding, where you were just typing text into a black screen?
Exactly that.
Why isn't there just a normal clickable interface for this in the scientific community? That sounds miserable.
Because in academia, it's about raw computational power and custom parameters, not user experience.
Right, they don't care if it's pretty.
Exactly. But SpartaDNA has taken this incredibly complex, intimidating academic tool and integrated it directly into their web platform.
Why?
They built a graphical interface for it, allowing everyday users to create extremely fast models running against a database of nearly 22,000 specific QPADM samples.
So what does this all mean? I mean, think of it this way. It's like being handed the security badge to a top-tier, multi-million-dollar university genetics lab.
Yes.
You get to walk in, use their supercomputers to run your own biological samples, and see the exact same data the professors see. But, and this is a massive pullet, but the lab immediately shreds your raw biological sample the second they finish the scan.
Yes. The privacy architecture here is paramount.
Yeah, we have to talk about privacy.
When we are dealing with raw genomic data, the security of that file is the primary concern for most users, and rightfully so.
Absolutely. The platform encrypts all the data, but more importantly, your raw data file is immediately deleted the absolute moment that G25 vectors calculate.
Completely wiped.
They don't store your raw text file on a server somewhere waiting to be hacked. They extract the coordinate map they need to run the historical tools, and they instantly trash the original file.
If we connect this to the bigger picture, what we are witnessing here is the true democratization of science.
Oh, 100%.
The fact that you can upload a file from a $60 commercial test and suddenly run the exact same QPADM analyses that researchers use to write peer-reviewed anthropological papers is a massive shift in power.
It really is.
The tools of human discovery, the ability to decode our own past, are no longer locked away behind the closed doors of academia.
It really is a paradigm shift. But so far, we've spent a lot of time in the deep past. Right?
Yeah, ancient history.
The Bronze Age, the Neolithic migrations, ancient academic samples. How does that ancient code dictate how our physical bodies operate right now, today?
Yeah.
Because the platform doesn't just look backward.
No, it looks inward. SpartaDNA includes a comprehensive traits and health service that maps your DNA against current genetic research.
And it checks over 6,000 genetic categories. 6,000.
It's incredibly thorough.
It looks at your predispositions to everyday things.
Yeah.
It can tell you why you might be genetically prone to a caffeine addiction,
Guilty.
right? Or your likelihood of male pattern baldness, your baseline memory retention, and even your musical aptitude.
It also scans for specific genetic markers related to very complex biological conditions.
Oh, like what?
For example, the system checks for responses to 17 alpha-hydroxyprogesterone cap rate and markers for 21 hydroxylase deficiency.
Okay, you just lost me. Those sound incredibly intimidating, especially if you were just a regular person reading them on a screen.
They are a mouthful, yeah.
What do those actually mean in plain English?
Okay, to simplify it, those are complex markers that relate to how your body's adrenal glands function.
Okay.
21-hydroxylase deficiency, for instance, involves how your body produces essential hormones that manage stress, salt levels, and blood pressure.
Wow, okay.
Seeing a flag for something like that on a website can naturally cause panic. Which is exactly why I have to jump in right here, because this raises an important question regarding how we responsibly consume personal genomic data. And SpartaDNA makes a huge point of this.
Yes, let's emphasize this.
These health traits are absolutely not a medical diagnosis.
That is such an important clarification to make.
The system is doing statistical matching. It finds a marker in your DNA that research studies have correlated with a specific trait or deficiency, and it flags it.
Right, it's just a flag.
Exactly. You should never, ever use a platform like this to make medical decisions or change your healthcare routine. It is strictly for research, curiosity, and perhaps, prompting an informed conversation with an actual licensed medical professional.
It's an indicator, a statistical echo, not a definitive medical chart.
Precisely.
But honestly, dealing with all of this, from the ancient QPADM admixture models showing your distance to a Bronze Age nomad, down to a list of 6,000 physical and hormonal traits, it is an overwhelming amount of information.
Oh, it is completely overwhelming.
Most of us don't have degrees in population genetics. If the system tells me I have a predominantly West Eurasian genetic structure with a strong Eastern Mediterranean orientation, I have literally no idea what that practically means for my life story.
And SpartaDNA recognized that barrier to entry. I mean, raw data, even when visualized on a beautifully designed graph, is still largely useless if it isn't comprehensible to the person looking at it.
Right, and here's where it gets really interesting. To solve that translation problem, they integrated AI directly into the platform.
This is such a smart feature.
It really is. There's a feature that uses large language models like ChatGPT or Gemini to take all of your complex multi-dimensional G25 results and instantly write a comprehensive, highly readable report.
And the prompt architecture they use for the AI is incredibly structured. It doesn't just ask the AI for a generic, fluffy summary.
Tell me about my DNA.
Right, none of that. It demands a rigorous breakdown. It forces the AI to provide a general interpretation, a distance-based analysis explaining exactly what those PCA plots mean, the historical and anthropological context of your specific migrations, and it even includes confidence notes clarifying any limitations or statistical noise in the data.
It is literally like having a personal genetic counselor sitting next to you.
Yeah, essentially.
They are taking lines of raw code and academic coordinates and translating them into an engaging, multi-page biography about your life and your ancestors. It takes that sharp academic edge and softens it into a human narrative.
It synthesizes pure data into a comprehensible human story.
And because it's the modern era, they have built-in social features to share that story.
Of course they do.
You can generate video reports of your DNA results, specifically formatted for social media.
Oh, wow.
Yeah, and they even have a feature where you can create a digital genetic passport or an ID card, complete with your photo, your nationality, and your primary maternal and paternal haplogroups.
That's fascinating.
I just marvel at the modern desire to take our most fundamental, ancient biological blueprints and post them on our feeds.
Well, I think it speaks to a very deep-seated psychological need for identity.
How so?
In a modern world where everything feels very transient and digital, having a passport that anchors you to a specific 5,000-year-old migration route provides a profound sense of grounding.
Yeah, I can see that.
People want to share that. They want to show that they are part of a continuous ancient chain.
They absolutely do. It's a way of saying, this is fundamentally biologically who I am.
Exactly.
So to bring all of this together, we started with a basic text file, the kind of raw data file you download from a commercial test, look at once, and completely forget about.
Right.
And SpartaDNA takes that static file and transforms it into an interactive, time-traveling encyclopedia. It charts your past through academic-grade tools like QPADM. It maps your present physical traits down to your caffeine habits. And it uses AI to explain it all to you in plain, accessible language, all while immediately shredding your data to protect your privacy.
It is a remarkable synthesis of big data, historical anthropology, and modern software engineering. I mean, it provides a level of resolution to our personal histories that simply wasn't accessible to the general public even a decade ago.
It really is the ultimate magnifying glass, or, the ultimate X-ray scanner for the insanely curious mind.
Truly.
But as we wrap up this deep dive, I want to leave you with a thought to mull over on your own. We spent a lot of time talking about how these academic tools can pinpoint the exact routes your ancestors took millennia ago, and how they can predict your predispositions to something as mundane as your daily coffee habit, or as profound as your ability to play the piano.
Yeah.
If so much of what makes us who we are is already mapped out in this ancient readable code, How much of your unique personality is actually just a statistical echo of the past? And how does knowing that your traits were written by ancient nomads change the way you view your own free will? Something to think about.